Assalamualaikum and a very good day to everyone. My name is Ammar Husni bin Zulkiffli, a final year student of Mechanical Engineering UiTM Shahrul. Today I am going to present my final year project proposal titled Analysis of Beam Deflection under Various Conditions using MATLAB. First and foremost, I would like to thank my supervisor Dr. Shahrul Azam Abdullah for helping me in this project. The panels for my final year project are Dr. Zuraidah binti Saleh and Dr. Abdul Halim bin Abdullah. These are the content that will be discussed throughout the presentation. As a final year student, it is a requirement to do a final year project under the subject MEC601. For the final year project 1, the project proposed is an analysis of beam deflection under various conditions using MATLAB software. The analysis of beam deflection will be focusing on two different types of beam conditions, simple supported and cantilever beam. This type of beam consists of many loading conditions that can be applied in the calculation. A new coding algorithm and mathematical modeling regarding the analysis of beam deflection will be developed using the information gathered. After that, a GUI program system will be designed based on the coding algorithm created. The outcome of this program will help students in understanding this topic better and build student confidence in their study. Next, I will move to the introduction part. Background of the studies. Deflection means the movement of a beam or node from its original position due to the force and load being applied to the member. Deflection, also referred to as displacement. Deflection can occur in any other body structure axis. Beam deflection is referred as the state of deformation of a beam from its initial shape due to a work of force, load, or wave. For the problem statement found in this project, beam deflection can be defined in many ways in their geometry and composition. Next, the topic requires some complex and complicated formulation for the beam deflection under various conditions. And lastly, because of the formulation and calculation were done manually, there could be human errors and mistakes happen and cannot be avoided. Next, the objective for this project are to develop the algorithm of the beam deflection under the various conditions. Next, to develop the GUI program of the beam deflection under various condition analysis using MATLAB based on the mathematical modeling and coding created. And lastly, to calculate the maximum deflection of the beam and the deflection load at any point as the outcome of these results. For scope and limitation, it will be focusing on the analysis of the beam deflection under various conditions by using MATLAB software as the main platform. Next, there will be limitation in analysis to develop the algorithm of the coding and the GUI system modeling. Next, the two types of beam is considered, which are the simple supported and cantilever beam. And lastly, there will be various beam conditions and shape and parameters inserted into the mathematical modeling. Literature review. For the beam deflection, the deflection of beams be related with the failure of the beam to perform to its original state due to the excessive deflection towards the beam stated by mode and internal, and it is inversely proportional to the moment of inertia. There are some limitations of the deflection in the structure, and a detailed analysis for the use of atomic force microscopy by the optical beam deflection by the Putman and others to show that beam deflection analysis can be applied in the different scope of studies. Meyer and Ammar were the ones who introduced the optical beam deflection technique being used widely in the laboratory. Mode and Internal also stated that the successive integration method is very useful to find the beam deflection at any point of beam by this equation. A simulation of the beam deflection made by Choudhury and others using the Visual Basic program as the platform to generate the results. Next, simple supported beam. Simply supported beam are the type of structural element that is often used in engineering by Lee and Lee. Then a few journals and articles were collected regarding the analysis of simple supported beam. The study by Timoshenko stated that the simple supported beam can be used to determine the mechanical properties of materials. Timoshenko also stated that a load deflection or a load displacement relationship is required to determine the mechanical properties of a beam. Conway also analyzed the problem of a simple supported beam at its end while carrying a mid-span concentrated load. Wang and others treated a class nonlinear problem of large deflection simple supported beam subjected to a point load via the shooting optimization technique by the Cantilever beam. The cantilever beam consists of many different cases stated by Mott and Internet. Bishop and Drucker developed an elliptic integral approach since the basic instructions are no longer valid. The approach developed by Dado and Alexander is approximates the angle rotation by a polynomial function. Meyer and Ammar minimizes the residual of the governing equation caused by approximation. And lastly, Chen proposed a new approach to solve the large deflection cantilever beam problem by using moment integral treatment. For other parameters related to the beam deflection, Ripple and others analyzed the effect of the uncertain parameters on the deflection of beams. Kidman and Cross analyzed the effect of the cross-section properties to identify deformation, stresses, internal forces, and others. Mott and Internet state that the moment of inertia is the stiffness of the shape that consists of the cross-section of the beam. Lastly, Rani made a calculation of the moment of inertia for various cross-sections by using C programming. Next, we will move to the methodology of the project. For the flowchart of the project, all the articles, journal, research paper, and book related to the beam deflection analysis were collected and be read through to enhance my knowledge towards my project and be used for the literature review. From the research finding, it can be used to identify what is the problem statement of developing this program. The purpose is to find the objective and identify what are the scope and limitation for my project. All the formulation and calculation gathered regarding the beam deflection based on this project scope are inserted into the coding. Once the coding writing is complete, the coding will be run to see if there is any mistake or problem to be fixed. After that, a GUI program will be built. Lastly, there will be an overall testing and evaluation for the whole progress. For the flowchart of developing the coding, it will start with the type of the beam to be used and chosen by the users in the program. Either it is simple supported beam or cantilever beam. Next, there is an if condition to decide the beam shape that consists of 6 different shapes to be chosen by the users. Then the users need to choose the type of the loading condition to be used. Then the users need to enter the length, loading value, and the modulus elasticity as the parameters. Next, there is an if condition for the moment of inertia. The users can just enter the value if the users have this value. Otherwise, the user have to enter the cross-section of the beam shape. The moment of inertia value will be displayed. Apart from that, the user have to enter the x value for the deflection at any section in terms of x. Lastly, the program will be display the value of the maximum deflection and the deflection at any section in terms of x. Next is the preliminary results. Firstly, the program will display that there are two types of beams, which are simple supported beam and cantilever beam that the users need to choose to start the program. Next, the program will display the type of the loading condition for each beam to be selected for the next command. After the users choose the loading type, the photo of the loading type will be displayed. Then the users need to fill in the beam length, the point load, and the modulus of the elasticity value. Then the user will be asked if they already have the value of the moment of inertia or not. The user will have to select between those two options. If the user chose the option 1, the user would just have to enter the value of the moment of inertia. If the user chooses the otherwise, it means that the user will have to choose the type of the beam shape. The picture of the beam shape will appear as soon as the user chooses the beam shape. After that, the users need to enter the cross-section of the beam shape choose. The value of the moment of inertia will be appear as soon as the user done finish entering all the value. To find the deflection at any section of the beam, the user must insert the value of the x based on the condition of the beam loading type chosen earlier. Lastly, the program will display the maximum value of the deflection and the deflection at any section of the beam at the end of the program. And lastly, program planning for this final year 1 project. The program planning consists of some project activities such as literature review, problem statement, objective and limitation, writing coding in MATLAB, develop the GUI system, overall testing and evaluation, logbook, proposal report, proposal presentation, thesis and technical report, and final presentation. The yellow color shows that the planning met for these activities, while the green one is to indicate the actual time needed for these activities. That's all from me. Thank you for spending your time and lending your ears throughout this presentation.